Hi guys, here's the video going over section 8.2, operations with matrices. So the first thing we're going to look at are equal matrices. So first off, what is a matrix? A matrix is a way of arranging numbers. So you'll see these brackets around a set of numbers. So in order for matrices to be equal to each other, they need to have the same dimensions. So let's talk about dimensions first. So dimensions of a matrix is rows by columns. So your rows are horizontal, columns are vertical. So if I look at my first matrix on the left-hand side, that has 3 rows, 3 columns. So this one is a 3 by 3. Second one, also a 3 by 3. And of course your matrices have to be the same exact size for them to be equal to each other. So what we're doing with this example is we are using these equal matrices to solve for particular variables. So what I'm doing is I'm going to look at corresponding elements. So each term within your matrix is called an element. So this x plus 2 is in the first row, first column. This 2x plus 6 is also in the first row, first column. And since these two matrices are said to be equal to each other, I can go ahead and set those expressions equal to each other. Now my 8 and 8, -3, 1 and 1, don't really care about those since they don't have variables. But I do have this w plus x, and that is going to equal 18, so I can set up another equation. And then I'm going to keep looking for variables. So I have y plus z, and that is going to equal 7. And finally, I have y plus 2, and that is going to equal 11. Now, I like to set up all of my equations first, and then I'm going to start the process of solving for things. So I'm going to go ahead and solve for x. I'm going to subtract x from both sides. That gives me 2 equals x plus 6. Subtract 6 from both sides, you get x equals -4. For w, it says w plus x equals 18, so now that I know that x is -4, I can go ahead and replace that in my equation. So some of these equations are going to use answers from other equations. So you kind of have to pay attention to what your equation is saying. So my next one, I have y plus z equals 7. Well, I don't know y or z right now, so I'm going to skip the blue equation and go to the orange, because my orange equation is actually going to let me solve for y. So y equals 9. And of course, now that I know that y is 9, I can use that to solve for z. So z is -2. All right, so the next thing we're going to be looking at is adding, subtracting, and multiplying matrices. So to add and subtract matrices, they have to have the same exact dimensions. If they do not have the same dimensions, then it is not possible to add or subtract them. So if I look at matrix A is a 2 by 2. Matrix B is also a 2 by 2, which means they're the same dimensions. So I can go ahead and evaluate 3A plus B. So I'm just going to rewrite this. I'm going to do 3 times A plus matrix B, and then I am going to simplify. So that 3 in front of matrix A, I can go ahead and distribute to those particular numbers. That gives me 6, -9, 15, and 21, plus this one, 8, 5, -7, and 9. And then I'm just going to add or subtract the corresponding elements. So I have 6 plus 8. Well, 6 plus 8 is 14. -9 plus 5 is -4. 15 minus 7 is 8. And 21 plus 9 is 30. And voila, there is your answer for this example. So adding and subtracting matrices is pretty straightforward. You're just going to add or subtract those corresponding elements. Multiplication of matrices, not so much as straightforward. I lost my train of thought there. Not as straightforward as adding and subtracting. There we go. My brain was just not cooperating with what I wanted to say. So multiplying matrices. Matrices can only be multiplied if the number of columns of the first matrix matches the number of rows of the second. So my example is I have a 3 by 5 and a 5 by 2, and I want to see if I can actually multiply those two. So I'm going to look at those two pieces of my dimensions. So this first 5 is the number of columns in the first matrix. This second 5 is the number of rows in the second matrix. And I want to see that those two numbers are the same, which they are, which means I can go ahead and multiply those two matrices together, and the result is going to be a 3 by 2 matrix. So the result, the size of your new matrix is going to be the outside numbers, so 3 by 2. So let's actually look at this in the context of an actual matrix with numbers. So it says, if possible, find A times B and B times A. So the first thing I want to do is I want to double check my dimensions. So I have A times B. Well, A is a 2 by 2. B is also a 2 by 2. Those two numbers match, so we're good to go. So my answer is going to be another 2 by 2. So I'm going to go ahead and write A next to B. B is 6, -2, 4, -7. And my result is going to be a 2 by 2, so I'm going to go ahead and set up a blank 2 by 2. Now you might be wondering why those spaces are so big. You'll know once we actually start doing the problem. So in order to multiply matrices, what you're going to do is you are going to pay attention to where that particular element is in the new matrix. So for example, this spot right here is in my first row and first column. So what I'm going to do is I'm going to take my first row and pair it up with my first column. So I'm going to multiply those corresponding pieces together. So 3 times 6 plus 1 times 4. So 3 times 6 is 18, 1 times 4 is 4. So that means my first element is 18 plus 4, which is 22. Now my second element in the first row is going to come from doing my first row with my second column, because the location of this element is in the first row, second column. So I'm going to do the same thing. So 3 times -2 plus 1 times -7. So that gives me -6 plus -7 is -13. And the process continues. So I'm now in my second row. So I'm going to do my second row with my first column. So that gives me 2 times 6 plus -4 times 4. Well, 2 times 6 is 12. Minus 4 is going to give you 8. Minus 4, that's minus 16. So 12 minus 16 is -4. Sorry about that, was not paying attention. And then for my last one, I'm going to take my second row, second column. So 2 times -2 plus -4 times -7. That gives me -4 plus 28, which is 24. And that is A times B. Now let's go in the opposite direction, B times A. B is a 2 by 2, A is a 2 by 2. Those numbers match, so answer will also be a 2 by 2. I'm going to go ahead and write out B first, then A. Now with matrices, order does matter when you are multiplying. So as you will see, A times B may not necessarily equal B times A. Okay, so I'm going to go first row, first column. First row, first column. So I have 6 times 3 plus negative 2 times 2. That gives me 18 minus 4, which is 14. First row, second column. So I have 6 times 1 plus negative 2 times negative 4. That gives me 6 plus 8, which is also 14. Now I am in my second row, so second row, first column. That gives me 4 times 3 plus negative 7 times 2. That gives me 12 minus 14, which is negative 2. And finally, second row, second column, so 4 times 1 plus negative 7 times negative 4. That gives me 4 plus 28, which is 32. All right, let's look at another one. So for letter B, this one I'm actually going to do in the calculator, mostly because I want to, and I don't want to work it all out by hand. And your calculator does have that capability, so might as well take advantage of it. So I want to do A times B first. So A is a 3 by 2. B is also a 2 by 2. Not also, B is a 2 by 2. Those two match, so that means the result is going to be a 3 by 2. So that is 3 rows, 2 columns. Now, as I said, I'm going to put this in my calculator. In order to do that, if you have a TI-84, you are going to hit alpha and then zoom, and that's going to allow you to put a matrix right on your calculator screen. So when you do that, hit alpha zoom, it's going to ask you for dimensions. So I'm going to type in, it's a 3 by 2. Oh boy, I'm having calculator issues, which you cannot see. Okay, so 4, negative 2, 1, 5, 3, negative 4, times matrix B, which is a 2 by 2. So that gives me 3, negative 2, 2, and 7. And I hit enter on my calculator, and that gives me 8, negative 22, 13, 33, 1, negative 34. And there's your answer for A times B. Easy peasy when you have the calculator. Let's look at B times A, so in the opposite direction. So B was a 2 by 2. A is a 3 by 2. Oh no! Those two do not match, which means I cannot actually multiply those two matrices together. So that right there is not possible. All right, so that concludes your notes for section 8.2.